Chapter 4, Section 5, Using Congruent Triangles. We've talked about the angle, side, angle, 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 side, 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 and side, angle, side congruence postulates for triangles. Now we're going to use the fact that we know that corresponding parts of congruent triangles are congruent to prove things other than the fact that we just have congruent triangles. I'm going to do 3 examples of a proof, 3 different proofs. Something that I want to make sure that you guys understand is that while I am doing a proof one way, there are other valid ways to do proofs. So if you have thoughts other than what I put, and especially if your order, you just see things in a different order, they could still be correct. However, this is just the way that I have written these proofs. So these ways are correct, but there are other correct ways that you could also do it. So let's start with our first one. We are given that HJ is parallel to LK, and we are given that JK is parallel to HL. Notice we're asked to prove that angle LHJ is congruent to angle JKL. If you look at angles LHJ and angles JKL, first of all, notice that we have 2 triangles, and notice that those 2 angles would be corresponding angles between the 2 triangles. So if we can prove that the 2 triangles are congruent, then I will be able to prove that the 2 angles are congruent because corresponding parts of congruent triangles are congruent. So let's start off first of all with our givens. That's always where you're going to start with your proof. So we're going to just rewrite what we were given. Remember, we've talked several times about 2 things that should be fairly obvious when we look at the diagram that they give us. First of all, in the 2 triangles that are formed, they're sharing the side LJ. So that would be one thing that would pop out to us, hopefully, and that because they're sharing the side LJ, we can use the reflexive property and say LJ is congruent to LJ because those 2 would be corresponding sides of the triangles. And if corresponding sides are congruent, then that can help us prove that we have congruent triangles. The other thing that should be popping out at us is that we have 2 sets of parallel lines. And again, if you look at the diagram, these 2 parallel lines are being cut by a transversal. The transversal in this case, again, is JL. So I'm going to start first, and it doesn't matter the order that you actually write those in. You could use the reflexive property first. I just happen to have the angles that are set equal to each other because of the alternate interior angles theorem. So because of the alternate interior angles theorem, I can say that angle HJL is congruent to angle JLK, and I can say that angle HLJ is congruent to angle LJK. Notice that because I'm using the same reason, I can put them together in the same statement. So I can say that by the alternate interior angles theorem. I can also say that segment LJ is congruent to itself, angle LJ, or segment LJ, because of the reflexive property of congruence. Now that I have 2 angles and the included side are congruent between the 2 triangles, I can go ahead and say that triangle HJL is congruent to triangle JKL because of the angle side angle congruence postulate. Now, I have not proven what they were asking me to prove. They were asking me to prove that angle LHJ is congruent to angle JKL. Because I have congruent triangles, I can say that these 2 angles are congruent to each other because corresponding parts of congruent triangles are congruent. If you look at that last reason, what I just said, once you have congruent triangles and you're trying to prove something further than just the fact that you have congruent triangles, that reason is going to be if you have congruent triangles, and then you're using the fact that the corresponding parts are congruent, your reason, what you're going to say is corresponding parts of congruent triangles are congruent. The next proof tells us that MS is parallel to segment TR and that MS is congruent to segment TR. And they're asking me to prove that A is the midpoint of MT. First thing I'm always going to do is start with my givens. The fact that MS is congruent to TR, we know that we have a congruent side. Again, because we are told that we have parallel lines, I should be thinking transversal, and if you look at the diagram, there is a transversal here. And actually, you can choose two different things on the transversal. There's not one right way to solve this. To say that these two triangles are congruent. I am going to use the fact that angle M is congruent to angle T and the fact that angle S is congruent to angle R, and both of those are because of the alternate interior angles theorem. We are given that we have parallel lines cut by a transversal, and so alternate interior angles are congruent. You could have also used the fact that angle MAS and angle RAT are vertical angles, and that would have just added another step to your proof. Both of those would be valid ways to say that triangle MAS is congruent to triangle TAR. Now, because I use the alternate interior angles theorem, and I know that two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, I would use the angle side angle theorem, or congruence postulate. Now, if you use the vertical angles and just one alternate interior angles theorem, then you would have angle side. Both of them are completely valid ways to write this proof. Both of them will get you to the fact that triangle MAS is congruent to triangle TAR. Now, this is where it gets a little bit tricky. And notice that it asks us to prove that A is the midpoint of segment MT. If you look at the two segments MA and AT that are on the whole segment MT, those would be my corresponding parts of the congruent triangles. So I can say that segment MA is congruent to segment TA because corresponding parts of congruent triangles are congruent. And then because the two smaller segments of the whole segment MT are congruent to each other, I can say that A is the midpoint of MT because of the definition of midpoint. Remember, the definition of midpoint is that it's going to cut a segment into two congruent parts. This last example, we are given that segment QT is the perpendicular bisector of segment US. We're also given that segment UV is congruent to segment QR, and that angle VQU is congruent to angle RQS. We are asked to prove in this case that triangle QUV is congruent to triangle QSR. It's always easier to do these when you can draw on the diagram. So if you will have this diagram in front of you, it's easier to draw what we know and kind of outline what you're trying to prove. In this case, we're trying to prove that, notice that there are actually 4 different triangles here. We're trying to prove that the furthest out triangles, so the furthest to the left and the furthest to the right triangles, are congruent to each other. We're always going to start with our givens, so go ahead and rewrite what you were given. The fact that QT is the perpendicular bisector of US tells us 2 different things. It tells me that UT is congruent to ST because of the definition of perpendicular bisector. Because of the definition of perpendicular bisector, it also tells me that angle QTU is and angle QTS are both right angles. Because those are both right angles, because of the definition of perpendicular bisector, I can say that angle QTU is congruent to angle QTS because all right angles are congruent. Also, if you notice my innermost triangle, my two middle triangles are sharing the segment QT. So I can say QT is congruent to QT because of the reflexive property of congruence. Now that I can say that triangle QTU is congruent to triangle QTS because of the side angle side congruence theorem or postulate, I can use the fact that my two smaller triangles in the middle are congruent to say that corresponding sides of congruent triangles are congruent, which tells me that QU is congruent to QS, which then allows me to tell you that triangle QUV is congruent to triangle QSR because of the side angle side congruence postulate again. So I actually had to end up proving that two sets of triangles were congruent so that I could use the fact that corresponding parts of congruent triangles are congruent to tell you that the two triangles they were asking me to prove are congruent. Today's assignment is on page 232. It's numbers 4 through 18, 22, and 23.